So this problem, again, is classic. It's so classic that I actually pulled this from an old exam that I've used, right? Which says, given a list of words, what I would like back is all the words that were in that list and how often each of those occurred. So for instance, if your input was foo, bar, baz, I would get back foo occurred twice, bar occurred twice, and baz occurred once. If I gave you A, B, A, C, A, D, I would say A occurred 3 times, B occurred once, C occurred once, D occurred once, right? So the key to figuring out these problems is like figure out what is your key and what is your value. And with counting, that's pretty much fairly straightforward. The key is the type of the thing you want to count, and the value is an integer because you want to count things. It doesn't really get more simple than that. Sometimes there's like some kind of variation, like an average, and that requires a couple different steps to do. But overall, it's fairly straightforward to do this. But this is kind of the classic thing. Categorizing is, again, another thing altogether. But this is counting. So how does this one work? Let's see. View, first off, code. Reformat just in case. Okay, great. So first things first, I'm just going to return null here to just squash the error. So our map, again, is the things we're counting are strings. So that's the key. And the value is, well, we're counting them, so it's an integer. We're mapping strings to integers there. Okay? So, now, what do we do? Well, for each word, this isn't going to be the first line of code in there, by the way, but I'm just going to give myself the for each loop. For each word in words. Okay, so let's go ahead and make our hash map. So map string to integer map is equal to a new hash map map dot. So now this is pretty much all we need to do to get it set up. So for each word. So let's go ahead and just assume that I have not seen this word yet. So if map dot contains key word, right? That will return true if I've seen the key. If the key's in this map, right? Have I seen this key before? Have I seen this word before? If this returns true, then yes, I have. So I'm going to assume I haven't seen this before. So if this does not contain the word, well, now I've seen it. How many times have I seen it? Well, this is well, it doesn't have it in there yet, so I haven't seen it yet. So this is the first time I've seen the word. So I've seen the word exactly once. So we'll say put so map.put word m1, right? Because I've seen it once. So if I've not seen the word before, right? If the map does not contain the word, I put in the word in my map, and I say I've seen it once. So the other case, I haven't seen it yet. Sorry, I have seen it. So this was, I haven't seen it yet. Now we're at, I have seen it before. Okay, so this is something I've seen before, right? I've seen, if I haven't seen it, that's obvious. But if this returns false, then there's only one other choice. I have seen it. So, how many times have I seen this word before? Int, let's go ahead and give it a nice long name, occurrences. Is equal to map.get. Oh, this number were used. Map.get word, right? So that's the number of times that I've seen it. Let's go ahead and actually make it something easier to spell. Times seen. So this is the number of times I've seen it. And now I've seen it one more time, so what I'm going to do is I'm going to do map.put word, the word I've just seen, times seen plus 1. Right? And then return the map. And that, believe it or not, is it. So for every word in the list, if I haven't seen the word, well, now I've seen it once. Otherwise, I get the number of times I've seen it. And then I say, then I've seen this word, and replace the number of times I've seen it with the value I just got plus 1. Right? Because I've seen it an additional time. And then I return the map. That's it. That's all you need. It's kind of brilliantly simple. Therein lies the reason we use it. So let's go ahead and make a list of words to test this out with, shall we? Let's go ahead and comment this out so that if you want to run this code, you can. List of strings is equal to L, new list, or new array list, whatever. Okay, L.add hello let's go Control C, Control V. Hello, L.add H U to okay, and now let's go ahead and do sout. So this is what we'll use to test this. So word count L. And so we run this and we find that the key to occurred twice, U occurred once, H occurred 3 times in the list, hello occurred 5 times in the list, and occurred once in the list. Seemed like it was a really hard problem, and it is, unless you have a hash set. Now the interesting thing is, how long did it take? It took O of n time. It took, so where n is the number of words. That's it. Why? Because put is a constant time operation. Checking to see if it has the word in there is a constant time operation, unlike list, which is a linear time operation, right? Getting it and putting another value in and overriding it, those were all constant time operations. Each of these operations in here were constant time operations, right? There were no for loops really inside of this thing, which is fantastic. Okay, how? Again, we'll get into that in later videos.